Okay. So here is the first part. Remember, this portion is differentiation. Now, don't suffer too much in this portion, okay? You have to be using the properties of the logs, correct? So, if, for instance, in this case, right here, E, you can take this as well. I have y equals x times 2 to the 2 log in base 2 of x minus 2. Of course, you can do this thing right here. Yeah. Let me just put it right here. Screen. So you see, this is the the problem we are going to solve, correct? So you have to take the derivative of these products. You have x times this power, this exponential function. Okay, but you have to recall your algebra. This is, you can do this product. Yes, you can do this product, but you can see 2 squared to the log. So in algebra, you learn that if you have a to the n to the m in this one, you can multiply the exponents, correct? So in this case, it's okay. I do some algebra. This is x, that doesn't change. I have 2 times 2 log in base 2 of x minus 2. Now, you also learn in algebra 1 and precalculus that n, the log in any base of u, is log of u to the n. So you can put this number at the front of the log as an exponent of the expression. So you have here a 2 in front of the log. So this is okay. This is going to be x 2 to the log 2 of x minus 2, correct? Yeah. Now, 2 and log 2. Well, what you learn also in precalc. In precalc, you learn that you have log in base a of a to the u. They cancel out and you get the u by itself. Or if you have a to the log a of u, again, you get the same u. You cancel out these two. Well, in this portion, what you have? Well, in this portion, you have 2 to the log 2 of x minus 2. So this is going to be y equals x times x minus 2. Correct? Because these two cancels, and then you get this one. Okay, now, this algebra right here, all this algebra is going to save you a lot of work because you can do this product and apply the formulas you have. And then you have functions of a function and also, but if you do some algebra, you get this simple. This derivative is going to be exactly the same as this one because these two are twin functions. So they are equivalent algebraically. So if you plot them, you see the same line. So if the derivative of this is the derivative of this. So this is simple, more algebra, x squared minus 2x, correct? And at the end, you have only to do your calculus, y prime equals 2x minus 2.
Ramirez.
Yes, ma'am.
What about the, like, whenever you did the power rule on the left side with the square, so x
This
minus
one?
2 squared, no, to the left.
This one from here to here?
No,
Oh,
like,
this one?
so 2, yeah, that power rule. Isn't that supposed to be a 2?
Yes, this is
Like
a 2.
squared, x minus 2 squared.
Yes. So you have this one right here. You have 2 to the log 2. So these two are the same, like here. They cancel. So this cancel, and I just get the x minus 2 back.
What about the n, though?
Of the n in this case is in this. Yes, you're right. Here is a 2, correct? Yeah, that's the problem. Yeah. So here is x squared. You're right. I forgot to put a 2. Very good. Okay. So in this case, the only we have to do is, okay, we can, this is x squared minus 4x. Oh, let me just admit these ones, right? minus 4x plus 4, right? So we expand this one, and then we get x cubed minus 4x squared plus 4x, correct? And then from this one, we get the derivative y prime equals 3x squared minus 8x plus 4. Thank you, me. I forgot this exponent. That changed everything because you have 2 and then you have to put it at the top. That's correct. So again, here is the philosophy in this problem. You have this complex expression, but you have to identify when you can do some algebra. So if you use some algebra, you can simplify the expression. Yes, possibly the algebra is going to be a little bit complex, but at the end, the expression you get to work with is simpler than the original one. This derivative, yeah, is going to be annoying. It's possible, but it's going to be annoying. This is simpler, correct? The values you get from this one are exactly the values you get from this one, for this derivative. Okay? What happened in the other problem? For instance, problem right here, F. Don't panic. Again, if you use some algebra, you save time. So you have y equals the log in base 8 of x squared minus 10 over a to the x. Correct? Okay. So what you have to do in this case is, well, the only you have to do is, yeah, use the properties of the logs. Is the log of all these expressions. So you remember that the log in any base of u over v, correct, u over v, is log in base a of u minus log in base a of v. Well, the only you have to do is split this one. So you have log in base 8 x squared minus 10 minus log in base 8 a to the x. Yes, sir.
What packet is this?
This one.
Huh?
It's the new homework he's posted.
It's H5003.
Mine is different, but it's the same number. What the heck?
Well, you have to go to Google Classroom and get it.
I don't see it on there though.
So it's a C here. There are two, C and H. Well, this is the H.
Oh, okay.
Come on, we have been working this way the whole year. Okay. Well,
Yeah.
now what happened in this last expression? What you do with this last expression? Log 8 of a to the x. What happened here? Nothing, something. What is going to happen? These two are going to cancel out, right? So, and then you do the derivative. Okay. Okay, well, let me see now the tangent lines. It seems that everybody's suffering with that. Okay, right. So it's very simple. So you have find the equation of the tangent line for the function 5 to the x minus 2 at the point 2, 1, correct? So let's see what happened in this case. Okay, no. Stop share. Okay, here it is. Here the point is very simple, right? You have a function, remember we did this before, an exponential function like this, and then at the point 2, 1, 2, 1, suppose this is the point 1 right here, yeah? you want the equation of the tangent line. So you need the equation of this one. So remember, this is y equals mx plus b. All the equations for a straight line are the same. But here you have a point. So this could be y minus y0 and x minus x0. So this is the point slope equation for a line, correct? A straight line. Now, because you want to know this, you need to determine who is who. X and y, well, those are the variables. So x0, y0 is the given point. So you have, correct? You have these two values already given. Now, but who's the m? Well, the m is the slope of tangent line. Okay, how do you get the slope of the tangent line? This is, well, the slope of the tangent line is given by the derivative. So if I want the slope of the tangent line, so m is the derivative evaluated in 2, because this is the 2, this is the x point, this is the, so it's the derivative in 2. So I have to take the derivative of 5x minus 2 and then evaluate this derivative in x equals 2. Okay? Really, this is the calculus portion of this assignment, so I'm going to put in the proper color. So it's y prime in 2, so it's the derivative respect x of 5x minus 2 at x equals 2. Correct. And this is a number. From this one, you're going to get a number. What you have to do with this number? Plug in that number here, and these two right here. This is the way to solve problem A to A and problem 2B. Okay? So what you have to do, well, derivatives of the log, derivatives of the exponential. Remember, this is the calculus portion. So derivative respect x of a to the u is a to the u again, the ln a times u prime, assuming that the u is a function of x, correct? Then the derivative respect x of the log in base a of u is 1 over the natural log of the base times 1 the reciprocal of the argument times u prime. So these are the formulas you have to use right here. Are obviously in the next problem right here. Okay? Now, the integration part. Let me just erase this portion, right? And let's suppose you have this page 3 right here. It's okay. All these problems have to be done by u substitution. Okay, what formulas we are going to use? Let me see, okay. Formulas we are going to use. Integral of a to the u is 1 over ln a to the u plus c. So the integral of this one is exactly the same function, except that you have to adjust a ln a, correct? And also, what else is you're going to do? Well, the other two integrals, you're going to have integral of e to the u du equals e to the u plus z, and the integral of 1 over u du is ln absolute value of u plus z. So we have these formulas. Oh, obviously, we have integral u to the n du equals u to the n plus 1 over n plus 1 plus c, and also the integral of cosine, the sine, and all those integrals. Let me just live with these ones, right? Right here. I'm going to have this, correct? So let's suppose you want to solve now, yeah, problem, for instance, Problem B. Okay, integral of 1 over the square root of x times 3 to the square root of x. Correct? So let me just put this one right here. Square root of x dx. Okay, I have this one, right? So this is my formula. Okay, well, I have to check at the left which one of these may help, right? This is okay. First one, I have this one, 3 square root of x, so it looks like this one right here, yeah? But this one, for instance, is in the denominator, and this is in the numerator, correct? Obviously, I have this function, but the derivative of this is not going to be 1, correct? I have only a 1 at the top. The derivative of this, that is going to be here, is not going to be 1. So this is going to be much more than 1. So I have to do some algebra in order to apply my formulas. Remember, this is the problem. So I'm going to take this expression and I'm going to put 1 over the square root of x times 3 to the negative square root of x dx. What I did? Oh, well, the only I did is recall my old algebra where 1 over a to the n is a to the negative n. This is algebra. So I'm using algebra here to rewrite this expression and try to match one of these here. Okay? So now, which one of these 4 is going to fit this one? This is, well, it's not an e, by sure. It's not this one. It's not a power, regular like this. So it seems that it's only going to be this one. So let me just fit then my thing. So I'm going to have a is going to be the 3. That's the base. So a to the u is going to be 3 to the negative square root of x. So u is negative square root of x, correct? So what is going to be the du? Okay, so u is negative square root of x. So du is going to be derivative of this one. Well, this basic algebra again is negative x to the 1/2, correct? So this is algebra. All the things in red are algebraic steps, correct? I just change this color only. All the things in red are algebra. Okay, now du is negative 1/2 times x to the negative 1/2. So it's going to be negative 1 over twice the square root of x. This is the derivative of this, and I have to multiply times the dx. Okay. So we just get more colors. Okay. Now I check what I have in my integral, correct? So I have a to the u. Okay, a to the u is this thing right here. Okay, no problem. The u is the square root of x. The differential du, so this portion right here, is all this portion right here. So it's 1 over 2 square root of x dx. Okay, I have here 1 over square root of x, same thing, dx, same thing. But I need a negative and I need a 2 right here. Okay. What happened? What is this blurry? Okay, there it is. Okay. So in my expression, the only I have to do is this. I have to put a negative 2 right here. Yeah. Group this one, so I have integral of 3 to the negative square root of x times 1 over negative 2 square root of x dx. So I'm putting this one right here. And then I need to cancel this negative 1/2 because it's the only thing I put here. So I put here a negative 2. Correct? So it's negative 2 integral 3x square negative square root of x times 1 over negative 2 square root of x dx. So This is 3 to the u, and this is du. So I'm going to change all my expression as, continue here, so it's -2 integral 3 to the u du, correct? And now, well, I'm going to see the answer. The answer is right here. A to the u du is 1 over ln a to the u plus e. Okay, so this is going to be -2 times 1 over ln of 3 times 3 to the u plus c. And then, what is the only thing I have to do? Well, the u is square root of x negative, so I have to substitute this here. And I have, well, let me just put this together already. So it's -2 over ln of 3 times 3 to the negative square root of x plus c, correct? So that's my answer. So check what I did. All the problems are going to be like this. So you have formulas to solve problems right here, integrals. Then you receive something. You have to match with one of these to solve it. You have sometimes to do some algebra to change your expression in something that is going to match one of these four, or one of these expressions. Then when you pretty much choose one to match, you try to set, okay, who's a to the u in this case, who's the u, well, they use this one, who's the u, okay, the u is the derivative of this times dx, and then you collect terms in your expression. It's okay, this one is right, this one is right here in this 2, this is right there, and the only I need is a -2, so I put a -2 and I remove the -2. These two cancel, and I get the same expression. I change the variable, solve the problem according with the formula, and then when I have the solution, I return the x's, and that's my solution. Okay, so all the problems in this section are exactly the same. You have to find what formula can solve your problem. Okay, let's work another one. Any question before I move? Everything fine?
Yeah, everything's fine.
Okay. Vamos a ver, por ejemplo, something like this, correct? Here you have pi to the secant x. So this formula, right, requires possibly some work. Let's see. Let's try something like that, right? So integral sine x over cosine square x pi to the secant x dx. This is, wow, it's a little monster, correct? Okay, vamos a ver. From the functions, well, the one that possible is going to work is this one, correct? A to the u du, so 1 over ln a times a to the u plus c. Okay, there is. So I'm going to try to match now this one. Okay, now, which one of these three has the same face as this one? Well, you don't have to think too much. It's the pi. So I make the pi is the a. So pi to the secant x is a to the u. So, well, the u is going to be secant x, correct? A secant x. Yeah. So you see, is this step-by-step matching. Pi is the a. Okay, it's a constant. A is a number. So the only number here is this one. Pi to the secant is a to the u. So no way out. U has to be secant x. Then the du. Du is derivative of the secant. Okay. Secant x tangent x dx. Okay. Now let's see what I have here in my integral. Okay. I have this portion. This portion right here is here. So this is a to the u. So I have here. So du should be all these three things, and I have all these three things right here. I have sine, cosine, this one. So, well, doesn't look very similar, these two, but I have to remember my old algebra or trigonometry. So I remember that tangent is sine over cosine, correct? And I remember also that the secant is the reciprocal of the cosine, correct? This red is algebra, correct? Algebra. This is okay. Let me just put in green, so don't make confusion about this one, okay? So this is tangent is sine over cosine, and secant is 1 over cosine, correct? So here my portions in red, yeah, du. So this is my calculus with my expression I have, right? So okay, well, with these identities, I can change my integral. So my integral now is going to be equals integral sine over cosine. So I'm going to use tangent and reciprocal of the cosine secant times pi to the secant x dx. So I use this in green to change my expression right here to this one. And this is pretty much the same as this one. You see, these three are this right here. So this is going to be integral pi to the u du. So this is the u and this is the u, correct? Now, solution. Here is the solution for this problem. So this is the reciprocal of 1 ln a times, no, well, ln pi times pi to the u plus z. And the only thing I have to do is substitute my value. So it's 1 over ln pi times pi to the secant x plus c. And here is my answer. So all the problems are going to be like this one. Is use substitution with a new formula. Okay? Nothing new. Questions till this point? Let me just check what is in the next page, the last one. Well, this one, yeah, these ones are fractions, correct? You see? Yeah, so this one is pretty much the same. Here is the u, and this is the derivative of this. The fractions, let's see the fractions also. The fraction, here, cosine x is the u, du, the derivative of the cosine is negative sign, so you have it here. So this is going to be solved in the same way. Possibly this fraction, this, and this one are going to give you some trouble, but again, the algebra has to be at work, correct? So let's see, for instance, this. So integral of a to the x over 2 to the 3x plus 1 dx. Okay, here is my integral. This is a fraction, so I have to check which one of the two formulas can help. So I'm going to see integral a to the u du or integral of 1 over u du. So in this case is, and in the second one is the natural log. Correct? So one of these ones. Okay, now, which one can be the formula to solve this? Says, well, suppose you take this one to fit this one. So you match the a with the 8 the u with the x, but you take the du, so the derivative of x is 1. And you have here something more than 1, so you have this expression that you cannot cancel. Okay, so now in this case, you have the fraction. So this u is right here, so this is the u. Now, the derivative of this is possibly this. Well, using algebra 1. So again, remember, a to the n times m is a to the n to the m. So you have here 3 times x, so you have this expression. So you can group the base with the first exponent and then raise to the second number. So this is going to be 3 to the 3x is going to be t cubed to the x. And what is t cubed? Okay, so my integral is going to be integral 8x over 8x plus 1. And this changed completely your expression, because now this is the u, and this, yeah, is proportional to the derivative of this. So you know now what is the u, okay? So you have to use now this function, correct? So some algebra. In problem, any question here? Fine. So understanding the algebra use? Okay. Let's see, for instance, now the next fraction, this one, okay? This is okay. I have something scary like this. Integral 2 to the ln x plus 1 plus 2 over x plus 1 dx. Now, again, my two functions is I have integral a to the u du or integral 1 over u du. Okay? So which one of these two you think is going to be the one? Okay, let's see this one. Let's match this one because it's a fraction. What is the derivative of x plus 1? No, that's a 1. But you have this bunch here at the top. This is not a 1. So this is not going to work. Okay, here. Suppose you have a to the u. This is, well, but I have this thing combined with this 2. And this has to be by itself. So this has to be alone. Okay, so I'm going to use again algebra 1. Algebra 1. If you have two numbers like this, a plus b divided by a single number, you know that you can do this split. You split this a plus b in a over c plus b over c, correct? So I'm going to do exactly the same. So this is going to be integral of 2 ln, no, let me just write it correctly. So it's integral 2 to the ln x plus 1 over x plus 1 plus 2 over x plus 1. So I do this division, correct? And then I use properties of the integral. So this is going to be integral 2 ln x plus 1 over x plus 1 dx plus integral 2 x plus 1 dx. There is. Now what you did, you split this block into integrals. Now, here you can see immediately that this is going to be solved by this one. A to the u is 2 to the ln x. The derivative of the ln x is 1 over x plus 1, correct? And this one is going to match perfectly this one. The u is x plus 1. The du is 1 times dx. So this is derivative. This derivative is 1. So you have that this is going to be solved with this u substitution and this with the u substitution. Okay? No questions? Everybody clear? Well, to finish today, I'll let you work. Last fraction here. This one. This is, oh my. Integral of 16x, 16 to the x minus 4 to the x plus 1 over 2 to the x, like that. Stop share. There it is. Okay, again, you see a long term divided by a single term. So using the same algebra 1, correct, the same algebra 1. Remember, this is the way to add fractions. I'm going to split these two. So this is going to be integral of 16 to the x, 2 to the x, minus 4 to the x, 2 to the x, plus 1 over 2 to the x dx, correct? So I have this. Now, here is my point. 16, 2, 4, 2, well, this is not a problem. This is going to be 2 to the negative 2. So I have to recall my algebra 1 again. Algebra 1 says that you have a to the n over b to the n. So you have two numbers raised to the same power, and you have a fraction. You can do a over b, everything to the n. So you can factor the thing. So in this case, what is going to happen, for instance, for the 16? 16 to the x, 2 to the x is 16 over 2 to the x. And everybody knows that 16 over 2 is 8 to the x. So you simplify the first number, you simplify the second number, and this one, remember, is 2 to the negative x, correct? So everybody understanding the algebra to solve these problems? Yeah, I told you, the algebra is important. Okay.